Now I'm going to solve these equations by completing the square. It takes a lot of space with quite a few lines, so we'll just perhaps start with the first one and see how far we get. So we've got x squared minus 6x plus 3 equals 0. Now completing the square on this, it's clearly come from x minus 3 all squared, because the rule is to halve the coefficient of the x term. And if we just think about expanding this back again, I'll get x squared minus 6x plus 9. Now from that expansion, I don't want the 9. In fact, the x squared minus 6x, what I actually want is plus 3. So tidying that up, minus 9 plus 3 is minus 6, and if we put that in. Right, now adding 6 to both sides, of course, we'll move the, we'll add 6 to both sides, so I'm left with x minus 3 all squared equals 6. To undo a square, the opposite operation, the inverse operation is to square root both sides. So I'm going to square root that side. What you do to one side of an equation, you do to the other. So I get left with x minus 3 equals the square root of 6. Now because we've taken the square root ourselves, we need to remember that there could be a positive solution and of course a negative solution. And actually you don't need those brackets anymore. Right, so that means x equals, we'll add 3 to both sides to cancel out the minus 3, opposite operation, add 3. So now it will be 3 plus or minus root 6. Right, perhaps we'll try a harder one like b, which is going to need us to halve the 7. So we'll erase that one we've just done. And I can see for b, it's come from an x plus, and we'll write it as 7 over 2. So it's come from x plus 7 over 2 all squared. And expanding that, we'll get an x squared plus, now 7 over 2x plus 7 over 2x should leave us with a 7x plus, and on the end I would get 49 over 4. So comparing it with b, the x squared plus 7x I'm happy with. I don't actually want the 49 over 4. What I do want on the end is a minus 1 equals 0. So putting in the next line, x plus 7 over 2 squared. Now that 1, we can replace that as 4 over 4. So I'll end up with minus 53 over 4 equals 0. And the opposite of minus 53 over 4, if we do the opposite to cancel that out, we'll end up with positive 53 over 4 on the other side. The opposite of squaring is square rooting, so to undo the square, we're going to need to square root both sides, leaving with x plus 7 over 2 equals, remembering of course we can find the positive or the negative, and actually the square root of 4 exists. This is the same as finding the square root of 53 divided by the square root of 4. So we can write it as square root of 53, which doesn't exist nicely. It's an irrational number, so we'll leave it like that, over 2, which means x will equal negative 7 over 2, plus or minus. And we can tidy that up even further if you like, by writing it in the form over 2 like that. Finished. Now we might just try one more, have a go at part E. This one, part E, is going to require us to start by taking out a factor of 2. It's not common, but it will leave us with a coefficient of 1 for the x squared term. So we'll try E. Let's take out the 2, leaving me with x squared plus 4x minus 17 over 2 equals 0. Now the nice thing about this is that we can divide both sides by a factor of 2. So this side, when we divide, left-hand side, when we divide by 2, we'll cancel out that. And of course 0 divided by 2 is still 0. So I'm left with just the bracket. Now that's clearly come from x plus 2 all squared. And if we just quickly think about what that would give us, x squared plus 4x plus 4. Now I don't want the 4. In fact, what I want is a minus 17 over 2 term. So tidying that up, x plus 2 all squared. Now the 4 we can write as 8 over 2, so let's think about that. I'll have a minus 8 minus 17 over 2, which will be minus 25 over 2. So adding 25 over 2 to both sides will cancel it out from the left hand side, and I'll be left with 25 over 2 on the right hand side. Square rooting both sides, x plus 2 equals, now the square root of 25 exists quite nicely, so that would be 5 plus or minus 5 over root 2, which doesn't exist nicely. So x will equal negative 2 plus or minus 5 over root 2. And we'll just have another look at that. We don't want the 4, what we want in fact is minus 17 over 2. 4 we can replace with 8 over 2, 8 divided by 2 is 4. Minus 8 minus 17 will be minus 25. Halves altogether. Right, one to go, we'll try F. So I'll just erase all that. And for F we're going to have to pull out the 2 once again, which will unfortunately mean we'll have a half so if we start with F this time, we pull out the 2, leaving me with x squared minus x over 2 minus 4 divided by 2 is 2 equals 0. Once again we can divide both sides by 2. I'll cancel out the 2 from the left hand side, 0 divided by 2 is 2. So I'm just left with the bracket. Completing the square on the bracket, x minus, and we need half of the coefficient of the x, so half of a half is a quarter. Expanding that, x squared minus a half x minus a half x minus a quarter, x minus a quarter is minus a half x. Multiplying it together on the end, you get 1 over 16. You can just check that if you like. Quarter times a quarter. Now I don't want the 1 over 16. What I actually want is minus 2. It's minus a quarter all squared. Now 2, we can write that as 32 over 16. So I'll have minus 1 minus 32 is minus 33 over 16 equals 0. And now it's up to us for our rearranging again, and you should be good at this step by now as well. 33 over 16 on the other side. Taking the square root, both sides. X minus a quarter. So minus root 33. Of course, the square root of 16 is 4, so that's nice. X equals. We'll add a quarter to both sides. So I'll get 1 plus or minus root 33 over 4.